the next question. So, what are all the various, because hyperparameters is something that we'll be, discussing about. So what are the hyperparameters that are pretty much common, and how do you tweak those hyperparameters to improve the model? Can you throw some light?
So the most important hyperparameter with respect to night Bayes is something called as Laplacian smoothing, okay, which is basically your statistical measure or constant that we use to ensure that we don't get zero probability case. And this is basically called as alpha. Okay. Now, when we talk about the multinomial Bayes models, the problem that we will encounter is with respect to something called as zero probability. Okay, zero probability case. What does that zero probability case is all about? See, what we're trying to do is we basically try and build the input features data set. So this could be X1, this could be X2, X3, so on and so forth. And you'll have your labeled data here, right? So output variable is there. It could be your pass fail or spam ham scenario. Now we are saying that the spam or ham class that we are trying to detect should basically be depending on the values that we have in the input factors. Say, for example, if you talk about email, email would contain many keywords. So given bunch of keywords, whether it is to be detected as ham or spam, that's the logic that we are trying to construct in night Bayes. Conditional probability. Given these keywords, will it be having more chance of having declared as spam? So when you talk about this scenario, the biggest problem is when you try to build your model on historical data, you might have, let's say, some sample data. Right? So let's assume that there are 1,000 emails. Now, when you build the model, you're only taking the keywords which are coming from these 1,000 keywords, so 1,000 emails. So you'll have a bunch of keywords. Let's assume that we have 2,500 keywords. We also call them as tokens. And our data set here will be converted into one hot encoded form. One hot encoded data frame, which contains whether basically ones and zeros, which representing whether the email containing that word or not. We're not worried about how many times it is existing. The same keyword might be existing multiple times. That is not the aspect that we are trying to capture here. We are thinking from a perspective whether the keyword is present in the email or not. Okay, for now, let's only discuss about that. So all the 1,000 emails, from those 1,000 emails, we were able to take 2,500 keywords or tokens. And with respect to these tokens or keywords, we are trying to define the probabilities for email being ham or spam. Till now, this is what we do. This is the training part. But what if you have to use this trained algorithm on new email? So as a user, you're receiving an email. And in this email, assume that there is a keyword which is not coming from this 2,500 keywords from the historical data. This is something new keyword altogether. Now, in this case, given this keyword, what can I say about the email? Should it be ham or spam? Now, from a training data perspective, by default, we will say that the keyword is not present. So if I try to imagine that there is a new word here that we are adding, let's assume that this is the new keyword that we are adding. So for this email, the word is not present. So, right. So this is your new email. This word is not there. And we have some words here, some words not there. Okay. Like this. The formula for night Bayes algorithm says probability of the category of the email given some class, right? It says spam, for example. We will take all the tokens that are there in that email, right? These are your conditions. So when you talk about this equation, the formula says probability of your class. If from the historical data, we'll be able to identify the probability of the class multiplied by probability of this specific keyword in the class. So if you're trying to measure what is the chance of the email being spam, then how much influence this word has in those emails, right? So if I already have spam and this word is present in those spam, that means it has more weightage. The word has more weightage to declare an email as spam, right? So this is with respect to the first keyword. Similarly, I'll have the second keyword. Similarly, I'll have third keyword. So on and so forth. This is the formula that we have with respect to your probabilities. So P1, P of 1, X1, P of X2, P of X3. This is the dot product that we get. Now, when I take this information, I get some value here, some value probably here. With respect to the new word, the email does not contain that keyword, right? So that means by default, I'll assume that it is 0. So what happens to my class? What is the probability of class? If I substitute 0 here, everything becomes a 0. So the chance of that email being spam is 0. If it is spam is 0, then you can think of trying to calculate probability of class being ham. But again, is this keyword present in the email? Yes. But in the historical data, do you have that the word present in ham messages? No. None of these emails have the word. So even for probability of that word, for ham is also 0, because none of the previous cases that word was present. So even for probability of ham, it becomes a 0. Now, the email can either be a spam, or it can to be ham or some other class if it is a multi-class problem. But from this logic, we are trying to basically see everything as zeros only. This is called as zero probability problem. And this is the biggest problem that you will have in knife-based. Hence, the knife-based algorithm allows us to alter the outcome by using or by introducing a smoothing parameter, which is called as alpha. This alpha can be a float value. It can take any decimals as well. Okay, so this is with respect to your problem that we're facing. To overcome this problem, we have that Laplacian smoothing constant that we apply. This will ensure that we have non-zero value given to our equation, the formula. So probability of your email given the class will become non-zero, depending on the formula, right? I mean, we have plus k given here. K is the constant that we basically pass. So you'll never get zero probability in such instances. And this is the parameter which actually allows us to define the performance of the overall algorithm. Yes, so that's about the important parameters. So I have taken a little bit more time to explain things.
Yeah, sure. I understand. So quickly, I'd like to address a couple of questions that people have asked. One is Swapnil. So many times, before Swapnil's question, I think there was Gautam. Yeah. So hi, sir, please make videos on monitoring and maintenance of machine learning models in production. So Gautam, currently we are in the process of completing our phase with reference to deployment. All right, we are on that phase. So once we have adequately covered most of the popular deployment techniques, then we will be, we'll be doing that. So our Saturday is going to be part of that. The Saturday series, as we call it, is part of that. So firstly, I would recommend you may try to take benefit from the existing thing that is going on every Saturday. Sometimes on Sunday we have it, the series that we have. So post that, we will definitely look up, and your suggestion is taken into advisement. We'll look into it. The next question is from Swapnil. Many times official mail goes to spam. Why it happens? What should we do to avoid this? Okay. So I don't quite understand by what do you mean by official mail. So are you talking about a mail from an official mail ID going to another official mail ID in spam? For instance, I and Sharat share a 360-digit mg.com mail ID, which is the core of it is Google, Gmail, right? The core of it is Google, Gmail, and on top of that, it is the official mail ID. So the firewalls and the protocols that are going to be put in place is going to ensure that it errs on the side of caution. Meaning, a mail accidentally going to spam is okay, but a spam accidentally coming in my inbox, because my inbox anywhere between 20 to 50 emails per day is what we receive. So if I'm getting spam mails as well into my inbox, that is going to be a little jarring note. But if there is somebody who sent me an email and this is my official email, then checking the spam is better. Every once in a while, as a policy, you must check your spam. The other thing that you could probably do is, if you are receiving mails from people and it is getting sent to a spam, generally when somebody sends a mail, they communicate. It's not like a mass mailing or a marketing mail. They say, I've sent you a mail. May I know your mail ID, sir? This is my mail ID. I'll send you a mail. So when you have such a conversation, it's prudent to also ask the sender's email ID, and if you have the time, immediately whitelist it before the mail is even sent, so that if it comes, it directly comes and sits in your inbox. So these are some of the precautions that you can take. The algorithm is not 100%, but it is very good. At least the Gmail algorithm is very good. The spam, 99.99% of the spam goes to spam, and 99.99% of the ham goes to ham. It comes to the inbox. So in that context, one or two cases, and then we are looking at a huge volume here. All right, we are looking at billions of emails that are being transmitted. So given that, you will have to, like I said, the algorithms are designed to err on the side of caution. All right, and therefore, if it is even slightly something new, or somebody is going to be looking like a spam, it'll try to give it as a spam rather than said, okay, maybe if it is not a spam, give it your choice. So that's basically my answer to that. Karthik has a question: what could be the value of kn, or could it be any value? Now, again, it is pretty subjective. I'll take that question, Sharad. So it is a pretty subjective kind of a thing. It is, again, with experience. Now, if you have really large amount of data, all right, and if you have large amount of features coming into play, then what happens is the probability values for each of those words is going to be that much lower. It is inversely proportional. If I have, let us say, 10 features, those 10 features are going to be repeated many times to be able to make the decision. But if I have 5,000 features, a particular word may appear in maybe 5, maybe 10, maybe 20 of the 2,000, 3,000 training records, maybe 20 times. So if you look at the probability as it is of that particular word or that particular feature, is going to be very low, 20 out of, let us say, 2,000. Now, if I'm going to put a very high K value, it is going to give enormous weightage to that particular word. All right. So in those kind of choices, we start with a very small, like Sharad said, you can have a float value as well. So you start with a very small value, and it's all about training and testing and validation. You have partitioned the data. You check different values of K. You slightly incrementally change or increase the value of K and check for it. And therefore, you will be able to get that. That's basically it. Sharath will probably just add one more input on that in a moment. More input variables increase accuracy. Will it also lead to overfitting? Overfitting It is an inherent property. More variables is when you say more variables, I'm assuming you're talking about the features. All right. So yeah, more variables is definitely desirable because we are taking into a lot more thing. But yeah, there is obviously a point of inflection. All right. So we have policies in place when we are doing a Bayesian classifier. We have policies in place. Now, for instance, you may decide to choose 3-letter words or more. Then you choose probably no, let me go for 4-letter words. All right. So through a trial and error, you will find that sweet spot, the point of inflection, which is going to give you the best accuracy for both train and test the highest values. And then you find the ideal thing. Now, mails that my organization receives, let us assume, when I were to create a classifier to have the ham and spam, would probably require 5-letter words, or let us say the Indian context. All right, we like to type long words, all right, big words, and we are pretty educated. The English speaking population of our country is pretty educated, so we use bigger words. All right, so when there are bigger words, probably when you're dealing with an algorithm for India, you may have a bigger word kind of a scenario. Probably if you look at it in, let us say, some countries where English is not the primary language, they may use very simple words. I will come. Okay. Please, meeting at 6. These kind of mails, when they are using, that is when it is, that is where we have the scenario where smaller words would be required to have the classifier. So it is case to case basis. Sorry, I